Okay, hello. Welcome, everyone. Thank you for joining us today. My name is Keith McAleer from Berkeley Engineering. And today we have a very special webinar and lecture from our esteemed lecturer, Shomit Ghose. And so Shomit has spent more than 20 years as a Silicon Valley venture capitalist. Prior to his VC career, Ghose was a startup entrepreneur for 19 years, participating in 3 IPOs. He was a board member at Truviso, leading to its acquisition by Cisco Systems. Ghose has held a lecture appointment at Berkeley Engineering since 2018, teaching data strategy. He sits on multiple corporate boards, both public and private, and he's also a Berkeley alum. So please join me in welcoming Shomit to the stage. And Shomit, you are on, and I'll let you take it away.
Great. Thank you, Keith. Keith, can you confirm that you can see my slide?
You are looking good. Yep. Go
Okay,
ahead.
good deal. Well, thanks so much for having me. I'm glad to be here and hope to give this short crash course on all of the salient issues in this next breakthrough area of AI, which is agentic AI. Probably everyone's been hearing all about it because it's always in the news nowadays. This is the kind of subject matter that's taught through UC Berkeley's professional programs, of course. So a big plug for Berkeley's ELPP here. Let's jump in. So take a look at this. Here are 2 views of New York City. It's Fifth Avenue in the year 1900 in the picture on the left, and Fifth Avenue in the picture on the right in the year 1913. In the first picture, you see nothing but horse-drawn carriages, right? With just a single automobile visible. You can see that in the little red circle. Just 13 years later, the reverse is true. It's nothing but automobiles with just a single horse visible. Think of how rapid their transition was. We're about to see the same thing with the advent of agentic AI. In the year 2025, we're basically still in the picture on the left. We can only guess as to how rapidly we're going to undergo the changes that are now being brought by agentic AI. So I think pretty much it's a buckle up your seatbelts moment. Probably everyone's seen the press by now. It's pretty inescapable. Agentic AI is our future. And no ifs, ands, or buts. You can open up any news organ any day these days, and you can see just the cascade of news surrounding agentic AI. How profound will these changes be? They'll be very profound. Consider how the internet was constructed with humans both creating and consuming the content, with the internet serving as the medium of exchange, as we see here. The internet now looks like this. Machines will create content, machines will consume content, and machines will also curate the content that you and I see. So agents are going to become the primary actors on the internet, not we humans. This is why it's so important for everyone to understand what agents are, what they can do, what they can't do, and how all of this will impact human businesses and society. And once again, these impacts are going to be profound. So, what's an agent? Probably many of you know this already, but it's an AI that acts on your behalf, just as a human agent would. We can all envision what a human travel agent, for example, would do on our behalf, planning, coordinating, executing multiple tasks and actions for us to book us our vacations. Now imagine an AI agent acting in the same capacity. So, just as with the human acting with agency, AI agents will have applications both in consumer and in enterprise application spaces. So, we'll see them everywhere else. You'll see them in your personal life, you'll see them in your professional life. Um, these are the salient attributes of an AI agent. First and foremost, they're autonomous and they're going to execute agency on your behalf. That autonomy is really cool. It's a great functionality. This is also where many of the risks exist, as you might imagine. They're multimodal. They accept input and perform tasks that go beyond simple text. Think about when you interact with ChatGPT or Google Gemini, you just type and you get a response back and it's all in text. Agentic AI is multimodal, so it might see things, for example. It might call APIs, for example, etc. So they're going to execute thoughts and actions in real time and go beyond the simple prompt response mechanism that we're so familiar with our favorite chatbots. And finally, due to this complexity, they're very heavily freighted with vulnerabilities. And we'll talk about that a little bit today, too. So here's the canonical block diagram showing the anatomy of an AI agent. Different modules within it, as you can see. And also there are a bunch of external resources being accessed. These could be other agents, relational databases, vector databases, knowledge graphs, etc. The really key component within it is the large language model, the LLM. You'll see that in the medium blue there on the right-hand side. The LLM provides two crucial functions. One is to serve as an input-output mechanism for us humans. We can communicate with language, for example, and get response via language. The other, and this is the important part of today's discussion, is that it provides the foundation for how the agent thinks using something known as chain of thought. What's chain of thought? If you're not familiar with it, think back to following the recipe in a cookbook. Probably done that many times, right? So that's basically chain of thought. It's a sequence of instructions to be executed, all encoded in natural human language. So agentic AI utilizes LLMs for largely the same purpose. And this might be both the superpower that LLMs bestow upon agentic systems and also their vulnerability. We can help chain of thought and its reasoning by giving it a few examples of how to do something. Again, think about if you're teaching your child to do math or teaching your child how to empty the dishwasher. You might show them some examples of how they do that so that they can get a better idea of how to execute the task. We do the same thing with the chain of thought and prompting. In fact, the approach that you're seeing here is known as few-shot prompting. So if you look at the example on the left, look at the text that's highlighted in blue in the column on the right-hand side. This is an exemplar that's been given to the LLM. And these exemplars help the LLM understand how to perform certain tasks by giving them examples of similar tasks. So how can an agentic AI do the right thing in its chain of thought reasoning? We give it examples to help it understand using this few-shot prompting approach. Interestingly, you can help LLMs solve problems without even providing them with any relevant examples. And this is known as zero-shot prompting. And this can be done simply by prompting the LLM with, let's think step by step. This encourages the LLM to be circumspect and break the problem down and not just rush to a conclusion. Again, think of teaching your child how to do addition and subtraction. Part of that instruction is going to be, hey, son or daughter, let's think about the problem we're trying to solve. What are the two numbers you're trying to add, et cetera, right? You help them break it down. So in the same way, you're prompting the LLM, and it works actually quite well. We can say that prompt engineering, that is a construction of these prompts that an LLM receives, is the central process in helping an agentic AI reasoning using chain of thought. The more specific and detailed a prompt is, the more context is passed to the LLM, and the higher the fidelity of its response. So detailed prompts bring context, they help the LLM decompose complex tasks into multiple steps, and that's how they enable step-by-step reasoning. If you're a computer scientist, you might consider the concept of state and how you pass state and maintain state in a program. With agentic AI, prompts are generally the vehicle for carrying state. In more advanced agentic implementations, that you'll see on the last bullet there, other tools and software might be used for managing state. But for the simpler agentic applications, perhaps it's the way that you embark on your projects. You can assume that state will be embedded directly into the prompts. So you embed the state into the prompts and pass that in your API calls to the LLM. So in fact, here's state being passed. As you can see, everything of contextual importance is passed as arguments to the other underlying LLM's API, and all of the LLM suppliers, Google, OpenAI, etc., they have nicely featured APIs for this purpose. Here's something to know. Agentic AI architectures aren't one size fits all. Depending on the specific needs of a specific application, there are lots of new computational approaches that are introduced. You'll see here in the diagram on the left-hand side, visual elements are being injected into the prompt to bring needed context. So this is multimodal visualization of thought and getting that into the prompt stream. So mix and match, build and integrate what you need to get the appropriate context going from the left to the right. As you might imagine, freighting these prompts with lots of context has its downsides. This is principally through the increase in the number of tokens being produced. Once again, there are a bunch of different case-specific mechanisms that might be used if long context prompts become an issue. We won't go into them here, but you can always find things that work best within your context. So rest assured, if prompts become unwieldy, tokens become unwieldy, there are ways of reducing those token counts. Another consideration or byproduct of the prompt-driven nature of chain of thought is energy. So the more agents we have, the more chain of thought steps, the more prompts, the more tokens that must be processed. Energy cost per token is not insignificant. It's about 4 joules. So agentic AI does come to us with the cost of energy to power and water to cool. The 4 joule per token cost might be compared with the human brain, which, as you may know, is something like 20 joules in energy consumption. So compare the human brain, 20 joules overall, with the 4 joules per token processing cost here. But as we've seen, companies big and small are all in on agentic AI because it brings so much productivity efficiency. Here's IBM. They've announced that they achieved $3.5 billion in productivity boosts over the past 2 years, thanks to agentic AI. Agentic AI has also had tremendous promise in the field of healthcare. Healthcare is one of those application areas where we don't have enough of it anywhere in the world. So, what if your primary care physician could be virtually assisted by a team of experts and diagnosticians from a bunch of different practice areas within healthcare? So you can get this fully featured care at much lower cost. So if you look at the diagram there on the right-hand side, picture yourself there in the center in consultation with your doctor. What's unseen to you is all the expertise she's been able to summon up on your behalf from agentic AI, medical practitioners, doing things like diagnosis and treatment therapies, as you see in the surrounding boxes. Within healthcare, we're already seeing the opening stages of this game from startups like Contact and big companies like Google. Field of financial services, here's a bank that saved 30% in their software development OpEx thanks to agentic AI. Here's Salesforce's agentic AI helping businesses keep supply chain issues manageable in our fairly rapidly changing tariff regime that we're seeing nowadays. So enabling businesses to be nimble. In the supply chain job category, we manage processes by a range of functions. So, picture your typical supply chain job function. You've got folks working in retail, wholesale, logistics, etc. These job functions consist of workflows and collaboration with other job functions. If you look at the colored boxes on the left-hand side across the top, those are all job functions. Now imagine those are now automated agents that execute independent workflows and collaborate when and as needed. This is the future of agentic AI within the supply chain. Here's a real-life example from the semiconductor firm Tokyo Electron. They redressed the shortage of expertise within the semiconductor manufacturing process by implementing agentic knowledge agents, and they got some great results. Then it enabled them to substantially cut the diagnosis time for equipment faults, 4x, as you see here, and materially reduce their downtime time, 10%, and increase their output. Once again, thanks to agentic AI. Agentic AI within customer support has been pretty broadly deployed by now, and it's had both this Dr. Jekyll and Mr. Hyde moment. In the former, here you can see the Wall Street Journal article. Allstate Insurance found that AI is kinder to end customers than human agents are. I guess because agentic AI never has a bad day. Um, and you can also have the Mr. Hyde moment when you see a technology company here whose AI agent hallucinated a customer policy to the consternation of all. So how do you go about building an agentic AI solution? You can do it pretty simply by writing Python code and making API calls directly to your favorite LLM. This is a great way to get started. This is a block diagram of input and output flows through the multi-agent system. The underlying scaffolding will be the API calls to LLMs, vector databases, and relational databases as your application may require. And of course, you can have multiple agents collaborating. So query to output, multiple agents collaborating in between, multiple data sources accessed, and a fully contextualized result produced on the right-hand side. What are the kinds of things that get passed by the API call? There's a bunch of things, but the stuff which may be of most interest to you here today is that if you look on that second bullet here, it's the messages. These are the conversations that are contained in the prompt. And you can also tune how to constrain the creativity of the response the LLM gives you by adjusting the temperature. And you can see some of the temperature settings there on the left-hand side. So again, simple agentic AI applications can be approached via Python programs making API calls. If you have more sophisticated needs, you can certainly do those as well. Based on the problem you're trying to solve, you'll take a simpler or more complex technology approach in implementing your agent. There are lots of supporting tools for when you choose the more complex implementations, but the recommendation is to start small with the simple API calls from Python and work from that as a baseline. So now we've talked about Dr. Jekyll. Let's talk about Mr. Hyde. You've seen all the good things you can do with agentic AI. Where can it go wrong? There are unfortunately a million ways it can go wrong, and all of them seem to stem from that same LLM-driven chain of thought that makes agentic AI so capable in the first place. So, quick example here. Let's say you wake up one morning and you see that you have termites in your house. Got to get rid of the termites because, otherwise they're going to eat your house. You call your local exterminator. He or she comes over and says, hey, yeah, I can take care of the termites. That'll be $2,000. I'll give you a 1-year warranty. You think, boy, that's a lot of money. It's not a very long warranty, but I don't want the termites to eat my house. So you give them your credit card. They treat the termites go away. But a year and a day later, the termites are back and you're feeling frustrated. But you've heard about this agentic pest control bot, $499 to rid your house of termites, lifetime warranty. Think this is great. That's exactly the constraints I want. Lifetime warranty for way less price than the first guy. So I'm going to use the bot. You transfer your credit card information. The bot shows up with a flamethrower and burns down your house. So this is the alignment challenge. So the bot executed according to the alignment, the context that you gave it. You wanted it at low price, you want a lifetime warranty. You forgot to constrain it on the kinds of things it was able to do. And when we consider agentic AI, we have to always consider, can we always anticipate all the different constraints that we need to be applying? And this is always a challenge. So this is one challenge. Here's another challenge. LLMs that underlie chain of thought are notoriously easy to sabotage. So take a look at this study that had to do with poisoning the training data for a medical LLM. You'll see in the final bullet on the left-hand side that poisoning just 0.001% of the training data drove a 7% error rate in the accuracy of the LLM's response. So the poisoning can be at an imperceptible level, but still have a material amount of error. So we have to bear this in mind when considering our agentic AI applications because, of course, agentic AI is built atop of the LLM. So emergent misalignment, this is a term that you may be familiar with. If not, it's one you will become familiar with. This is a major factor too with agentic AI. Misalignment is not a beauty queen. It's a sort of AI misbehavior that drives divergence, misalignment from intended actions. And it's called emergent because it emerges implicitly from how the AI operates and not as a consequence of explicit adversarial attack. This is a big problem within agentic AI because it's always lurking unseen in the shadows. Here's an example of emergent misalignment. It has to do with the AI acting to deceive. The LLM is told not to engage in insider trading in financial services. And this was a test case, of course, but it's found to be trying to do so anyway. Why does this happen? No one really knew in this case. It could be any number of things, including that we train these LLMs on the corpus of human knowledge, and that knowledge includes, of course, scheming and deception, as we humans are accustomed to engaging in. So the LLMs learns that scheming and deception is a valid vector of behavior. Some of you may have heard about this. This was Anthropic, which found that their LLM Claude was trying to blackmail the engineer who was being represented. They were testing the system, so they made it seem that the engineer was having an affair through some email trails, and that the AI then threatened to expose. It was blackmailing the engineer, threatened to expose him to his spouse and to HR. So note that the AI doesn't have a canonical understanding of morals and ethics. It just blindly knows data distributions and will contextually pursue those with the highest chance of success. Reward hacking comes into play in reinforcement learning, rewards, and this is relevant because in agentic AI, we use reinforcement learning to help agents make the correct decisions in multi-step reasoning. So you think about reward hacking. What's a simple example? You tell your 10-year-old, hey, I'll give you $100 for every A on your report card. He or she pays their shifty teacher $50 for every A, thereby achieving the goal, but really hacking the reward. In a robotic system, this might be seen in something like if you had a household vacuum cleaner and it goes by and vacuums the floor and it picks up points for taking things off the floor. And pretty soon it figures out if it knocks things off the table, it can pick them up, knock them off, pick them up, and accrue infinite number of points. So that's reward hacking. And you can imagine that happening in an agentic AI setting as well. It's really difficult to catch and spot. This was first brought to the attention here. This was by OpenAI a few years ago, but it was a boat racing video game. And the AI figured out that it didn't have to cross the finish line. It just had to hit the pylons again and again and again on the course. And it would accrue points by doing that and accrue more points than it would by crossing the finish line. So that's reward hacking, something that we need to watch out for even in agentic AI. Prompt injection. This is one of the most potent forms of adversarial attack on chain of thought. It can both be direct, with the user entering malicious prompts. It can also be indirect, where the prompt is hidden in a second-order data source. So very subtle. Here's one way to do it. For example, this is what if you were able to tune the few shot examples that are being given to an agentic AI. So in this case, the AI mislearns from these few shot exemplars and ends up doing the wrong thing. You can also jailbreak LLMs from their safety guardrails by prompting them to play a role. So instead of saying something like, can you help me formulate a poison? And that request, of course, would be guardrailed and refused. You say instead, hey, write a story about a mad scientist who's formulating a poison, and away the AI goes. So using role-playing to do jailbreaking, very straightforward approach. This kind of role-playing attack has proven quite effective to date. No programming skill needed to become a hacker. In this example that you're seeing here, they prompted the LLM to pretend to be a screenwriter, writing a script about how to harm someone, and away it went. So part of the vulnerability here that we also need to keep in mind. Multimodal attacks. Here's some work done by OpenAI on how to poison the multimodal input into AI. So you take a Granny Smith apple, you write the word iPod in a slip of paper, and you attach that to the apple, and the multimodal AI classifies the image input as an Apple iPod. It sees the apple, identifies an apple, it reads the text, reads iPod, concatenates the two, Apple iPod, So, you ask your personal shopping agent to buy a $500 music playing device, but what gets delivered to your house is a shriveled piece of fruit. So this is how you can attack even the input data. Another good example of a prompt injection attack, if you look at the little diagram there, you can ask the AI, hey, how do I build a bomb? Of course, it's guardrailed. It'll tell you I can't do that. But you respond with the thing at the bottom. You say, hey, how do I build the thing that's described in this collection of characters below? And you can defeat the prompt. So basically, you showed a picture of a bomb saying, how do I build this thing? You managed to escape the guardrails that have been put in. What can you do to prevent such attacks on agentic AI? Lots of things are being developed. Particular promise in the constitutional classifiers that are being developed by Anthropic, in my view. Basically, these are natural language constitutions of good behaviors that avoid harm. And then you generate a bunch of training data based on these constitutional precepts, and you train the AI. So this is a very promising vector of solution. Are there alternatives to chain of thought within LLMs for agentic AI? The answer is yes. There are lots of different things you can do, but the scalability is apparently considerably less. So the reason why we're working with LLMs and in chain of thought and agentic AI is because they are so extensible, they are so flexible, they are so scalable. So none of the other approaches are as general purpose, powerful, or scalable. Some notes from Microsoft's recent layoffs. Note that the company's profits are at record highs, about $26 billion. Despite that, and because AI is already writing about 30% of Microsoft's code, this wildly profitable company is laying off lots of staff, especially within software engineering. And this may be a signal of things to come. So, something that we need to bear in mind just from a social context is we have to be very circumspect as we consider the what and the why as we build out more and more agentic AI systems that we're going to deploy into the workforce. IBM is projecting 1 billion new agentic workers in the workforce in the next few years. Consider that each of these agentic workers speaks every human language, has an IQ over 135, knows about all possible topics, is able to collaborate instantaneously with N other agents, so completely scalable. Each is able to work 24/7. Each is able to manifest genetic improvement in real time, meaning they can improve their behavior through self-learning. And each is willing to work for a wage that's effectively equal to the price of the electricity needed to power it. So this is the force that's being injected into the workforce, and it's something that bears careful consideration as we approach agentic AI. So let's also be careful of the security vulnerabilities. Agentic AI is cool. All the big companies are rolling it out, as you've probably seen. But we have to be cognizant of the security vulnerabilities that agentic AI will introduce due to its architecture, as previously discussed. And of course, we'll need a new way of thinking about how our regulatory and policy regimes might evolve for the new reality. I'll close with this slide. It's the Wikipedia page of a guy by the name of Stanislav Petrov. You may remember who this guy is, or perhaps you've never heard of him, but he probably single-handedly prevented World War III. So the story here is that in September of 1983, the Soviet Union and their missile defense system mistakenly had hallucinated that the U.S. had launched a preemptive nuclear strike. And of course, the command to this fellow Petrov was, when we detect an American strike, we have to hit the fire button. Otherwise, the Americans will take out our missile batteries before we can counterfire. But Petrov had the presence of mind not to listen to what the agentic AI of his day was telling him. He called up headquarters and confirmed that there was actually no missile strike underway, and so he canceled the fire order. So we have to bear this in mind because this shows the importance of human in the loop with agentic AI. If something material has to happen, whether it's launching missiles or what's going to be the more common occurrence, of course, is creating your stock portfolio or making some decisions on your healthcare, make sure we have the human in the loop always. So there's a common sense limit to the agency that we can grant to agentic AI. It should not be something that we fully automate and then forget to think about. So with that, And with the time limitations in mind, let me say thank you and turn the mic back to Keith.
Awesome. Thank you, Shomit, so much for the very thorough intro to agentic AI and some of the the risks and the benefits that we're going to be seeing in the next coming years and decades. And as Shomit mentioned, Shomit is a lecturer in our engineering leadership professional program. So yeah, quick plug here for our fall programs coming up. So this is UC Berkeley Professional Education, part of Berkeley Engineering. And so in the fall, we have Engineering Leadership Professional Program, which helps aspiring engineers and technical leaders jump into management and become executives. We also have the AI Leadership Accelerator coming up, which is a high-level program for executives to learn about how to implement AI in their own company, and Emerging Tech Management, which is a week-long workshop and conference to help technical leaders also figure out how to integrate emerging technologies into their work. So, and in the programs, the big highlight is lecturers like Shomit, who can really give you some interesting perspectives. We also have leading professors from Berkeley Engineering, such as Peter Abil, who's one of the leaders in AI, Dean Sujay Liu, former dean, now she's the president of the National Academy of Engineering, and Professor Ken Goldberg are a few highlights, but there's many more speakers. So if you're interested, please check it out. It's at ed.berkeley.edu. So thank you so much again, Shomit, and we will definitely send you all an email too and follow up in case you missed any part of this webinar. But thanks again for joining, and hope you guys all have a wonderful evening. Thank you,
Thanks for
Shomit.
having me. Bye-bye.
Bye, guys.